Question 3, the photograph shows an electrical appliance called a toaster. In part A, the toaster has a power 1800 watt when operating at voltage of 230 volt. State the equation linking power, current, and voltage. The correct answer is power equals electric current times voltage. Okay, this one I get 1 mark. Shall I write symbols? Yes. Power equals current is I, voltage is V. So this is for section AI. For section 2I, show that this is an effective and important keyword. The current in the toaster is about 8 ampere. How can I get this? I equals P divided by V, or power equals I times V. Okay, let me use P equal I times V. 1800 equals the value of the electric current, which is unknown, times the voltage at 230. So current, which is I, equals, you have to say 1800 divided by 230. The correct answer for this question is 7.826, which is approximately 8 ampere. Show the examiner this value. Show the examiner because he was asking for show that. Show that in physics we need 2 to 3 significant figures. Triple I, which fuse rating would be suitable for the toaster and definitely is not going to be any value less than 8 ampere. So the correct answer is 13 ampere, which is D. Section B, the toaster uses mains electricity. Mains electricity provides alternating current. Describe the difference between alternating current AC and DC. Okay, I know the DC from the battery or the electric cell. So the DC is the flow of charges, for example, from the positive terminal to the negative terminal, and this one is the definition of the conventional current. So it means that the flow of charges in one direction. So I get 1 mark for the DC. But for the AC, what does it mean? Here is a kind of a fluctuation and we change in the polarity. So I would say the flow of charges in one direction, and now it's still a DC, but I have to add then the other direction. So now I show the examiner the difference between DC and AC. Okay, section or the last section, state a source of direct current. The famous source is battery or the electric cell.